For his sensational contribution to the field of material science, Michio Kaku has, as a general rule, confirmed that the James Webb Space Telescope has detected 6 enormous structures that experts once thought could not exist. These findings have the potential to open new perspectives on how we understand the universe. The discovery is both exciting and groundbreaking, challenging existing theories about the development and evolution of galaxies. It is therefore important to stay updated on these developments. The endorsement by such a recognized expert highlights the significance of these discoveries. Michio Kaku is a remarkable figure in the scientific field, a physicist of American and Japanese heritage. He is regarded as an expert in both traditional experimental physics and quantum mechanics. Unlike some more conservative and skeptical experts, Kaku has been open to the surprising results of the James Webb Space Telescope mission. His eagerness to embrace new discoveries and share them with the public shows his commitment to advancing our understanding of the universe. We are pleased that this respected scientist has chosen to break his silence and openly share what can no longer be denied. The enthusiasm and almost engaged tone of the famous and brilliant physicist are evident in his remarks on the discoveries made by the James Webb Space Telescope, demonstrating that this is a subject that has sparked his interest. Join us as we explore the implications of Michio Kaku's discovery of these 6 massive galaxies. Kaku is a researcher who has always been willing to consider new theories. Throughout his life, he has shown an openness to ideas that challenge conventional understanding, recognizing that Einstein's theories of relativity and Newton's laws, while fundamental, are insufficient to explain the full complexity of the universe. Kaku acknowledges that the findings from the new telescope have the potential to advance the field of cosmology. However, many of his colleagues have yet to adopt this view, leading to concern and restlessness among Big Bang proponents and critics of quantum mechanics. Nevertheless, this only draws laughter from Kaku. The JWST has uncovered the discovery of 6 giant galaxies dating back to the earliest times of the universe. Each of these colossal galaxies contains more stars than our own Milky Way, despite having formed just 200 to 700 million years after the Big Bang. The group of space experts who made this discovery has named these brilliant galaxies universe breakers, as once confirmed, they will undoubtedly change our understanding of the universe. The implications of these discoveries are enormous, suggesting that the universe's early years were much more robust and complex than previously thought. Something no longer fits here. The hypothesis of how things came to be tells us that the universe was chaotic after the initial event. The first solid objects took a vast number of years to form, and it took significantly more time for these objects to reach sufficient density and produce light. The development of complex structures like galaxies was believed to occur much later. Some of the newly discovered galaxies dwarf the Milky Way in size, and their immense brightness suggests that they were possibly forming many new stars each year, while our system forms stars sporadically. It remains unclear exactly when the first galaxies formed, as analysts have yet to settle this. The only clear thing is that initially, there could have been only single stars or groups of stars, which eventually merged to form large structures until dwarf galaxies evolved. Smaller galaxies grew over time into remarkably large and massive galaxies, which were once thought to be incapable of existing at that time. This raises the question of whether the universe is much older than recently recognized, or whether complex cosmic structures formed significantly earlier. This scenario is difficult to accept for traditional science, which still finds issues with this model. Some segments of physics have strongly dismissed this discovery and questioned possible errors in the age estimates. Kaku is aware of this and had this to say: "There are various models of old and misleading theories that stubbornly persist due to the influence of certain experts. Many of these theories were only exposed when fundamental analysis revealed their flaws. Thus, the watchword in any science, especially in physics, lies with the experimentalists who keep the analysts alert and attentive. On Earth, we have very little actual information about the true origins of the universe." This statement from Kaku emphasizes the importance of constant experimentation and validation in the scientific process. The theory of how things came to be was established in 1927, based on observations of the universe's expansion. This data led to the conclusion that the universe began from a specific point and has been expanding ever since. At the time, it was difficult for people and experts to imagine a universe with both a beginning and an end. The idea of a universe that had always existed and was infinite in scope was beyond human imagination. Even today, researchers still struggle to comprehend it. However, it is essential to consider these possibilities, whether or not these new discoveries align with what scientists have accepted for decades as the theory of the Big Bang. Science has consistently shown that reassessment and openness to new ideas are essential for groundbreaking discoveries. Just like the acceptance of certain theories and observations when Einstein was young, it was once believed that stars and planets were firmly fixed in the universe and that these particular planets occupied a defined space. However, we now know that everything in the universe is moving. Planets orbit stars. Stars move within their galaxies at speeds of several kilometers per second, and entire galaxies travel rapidly through the universe, whose fate we still cannot predict. This remarkable understanding of the universe challenges long-held beliefs and highlights the need for constant inquiry and change in scientific thought. Today, researchers are challenged to accept uncomfortable truths and realize that theories are not absolute but valuable insights until they are thoroughly tested or confirmed by precise observation. The concept of the Big Bang emerged from the realization that galaxies are receding from each other, and this distance is relative to their separation from Earth. This observation, known as Hubble's law, suggested that the universe was expanding over time. Factors like cosmic background radiation and the redshift of light from distant galaxies, along with other cosmological patterns, seem to support this theory. However, it is important to remember that in the past, people who believed the Earth was flat and that the sun revolved around us also had observational evidence for their beliefs until new events or technological advancements provided a clearer picture. Right now, we are witnessing a similar situation. Scientists speculated that the new James Webb Space Telescope would confirm doubts related to the Big Bang. However, they have instead encountered these 6 galaxies that appeared impossible. This shows that science is constantly evolving, and scientists must remain open to new discoveries and reconsider existing theories based on available evidence. The surprising discoveries have challenged current understanding and prompted a reassessment of well-established cosmological theories.